So in order to make this into a min heap, I have to supply my own compare function. So compare function will be one of the arguments that I have to put inside the angle bracket. Okay. So I'm going to use I'm using priority key of string, and the compare function is the third argument. The second argument is vector of whatever type you're storing into your heap. So in my case, the second parameter will be a vector of string. Okay. Why vector of string? Because we know that the implementation of a heap is basically an array, and we skip the zeroth element, right? And the third argument of my priority queue declaration will be my own compare function. The default compare function is the last function. If you use the last function, you will get max heap. So now if you want to get a min heap, you want to use the greater function. So that's how you declare a max heap. I mean min heap. Okay? So the default function here with a min heap, with the max heap, the compare function is less. Compare function is less something. So if you change that to a greater function, then you're going to get a min heap. So now if I run the same program again, so the first output is not going to be zoom, the first output will be ASDF. Okay, so now we turn that into a min heap. Right? Question about max heap and min heap in C++.
What's
yes,
the vector strings for?
What is the vector string for? We have to provide a container that support front, begin and end. So something that can do front, something that can do begin, something that can do end. Okay. So let me show you the API. So the API will tell you that C++ reference, and if I look up the priority queue, so the parameter, in order to declare priority queue, you have to supply 3 arguments, but the second and third argument are given default values, so you don't have to supply anything. So the default container type for a priority queue is a vector of something. Okay. Why do I have to supply a vector of string? Because I want to change my compare function from less to greater. I cannot skip to the third argument unless I put something on the second argument. So that's why I have to say vector of something. Okay? Because my goal is to replace the less function with greater, but I cannot skip the second argument. Okay? So now let's work on the Huffman encoding problem. So with Huffman encoding, I have to create a pair of, a priority queue of pairs, right? Because each entry in my table will be a pair of character and count. Okay. So how do I build that? So let me just put that into a main 0, so I can start a new main. A new main here, and I'm going to declare a priority queue of my entry will be a pair of character and int. Which one do you want to put first? The character or the integer? Okay. And for this one, I do have to supply my own compare function, because I want to compare only the integer value, right? I want to compare only the integer value. So I cannot skip the second argument. I have to supply the second argument. The second argument will be vector of my type, vector of pair of character and int. Okay, and the third argument will be my own compare, my compare function. Okay, let me call it Huffman table. Okay, question about that long declaration. I cannot use less, I cannot use greater on my third argument because less is not going to guarantee me to compare the second argument only. I want to compare only the second field of my pair. Okay, so what is my compare functor? If you compile that, it will give you an error because my declaration is not complete. I have to supply the functor, which is my compare functor. Okay, a compare functor is just a class that has a public function. The public function is just the operator function call. Okay, so this will be the comparison function, and then it has to return true or false, right? Okay, now this will be the compare function, the comparator function. So what am I comparing?
Two pairs.
Two pairs. I'm comparing two pairs. So I have to put the first pair in here, the first pair in here, and the second pair up here. Okay, let me call it 1 and 2. Let me call it 1 and 2. To make my code more efficient, I want to pass by reference. Okay, and I'm not going to do any modification to my pair, so I'm going to pass it as const. Okay, but my pair type is incomplete. I have to say pair of character and int, and pair of character and int. Question about that long declaration. Okay, let me make them neat so then you can see. Okay, any question? And what should I compare now?
One second.
1 second. I do want to compare 1.second with 2.second, right? Because I want to compare only the integer. Okay, and I do want to make it a min heap. So in order to make a min heap, I have to compare for greater, right? Okay, because I want to make it a min heap. Question about that function. I know it's a long declaration. So I want to compare only the int part of my pair. That's why I'm using second. And I want to make my heap into a min heap. That's why I have to use the greater function, the greater comparison, right? So it will return true or false. So basically that's it for the compare function. It's a short one. Now, how do I insert into my Huffman table? So you can use insert, but using mplace is an easier way. Okay, mplace. I want to insert a pair. Let's say if I use this example before, letter D is how many times? 1 time. Okay, and then keep going. Letter E, how many times? 7 times maybe? I don't remember. F 2 times. Well, that number is not important. Okay, the number is not important. Okay, so now the more important problem is how do you actually build the frequency, right? If I from a real string. So if I give you an input string, here, how do I build that table? Okay. So let's say the string that I want to use as my reference just something, I don't know, just type some junk. Okay, I'm going to use this as an example for my encoding. This basically I want to get the count of the letter frequency, right? And I don't want to see any space, so remove any space there. I don't want to see any digit. So what I can do is I can create a map of character and int to keep my frequency counter, letter count, okay, and then I can go to my loop, right? I can just start a loop for each character C in text. I'm going to update my letter count. I have to include map. I have to include map here. Include map. And then map. Letter count. So letter count C++. Okay, so I know the input. I know I'll get the frequency of each letter from using that simple loop. And then from there, now I can insert that entry into my table, right? So tell me what to write in order to insert the counter into my Huffman table.
If you don't find it first, then
Do I need to do any if statement?
oh no.
I don't have to do any if statement.
Use the increment every time for every letter.
So I can just run through the map, right? From the map, I will get the letter and the frequency, and then just insert that, push that pair into my Huffman table. Are you still with me?
Yeah.
Okay. So I can just push that into my Huffman table. Huffman table dot push. Do I need to reverse the order? Unfortunately, no. So I'm going to use mplace, okay, because the first has to be my character. It will be n3 dot first, and then n3 dot second, right? Okay, let me stop here. Make sure you are following my code here. Any question? Stop me anytime. Right? So what I have in my map is just a 2-column data, right? My map is just 2-column data. So let me do it slower. My map is just a 2-column data. So what I have from the first loop, from the first loop, I will know like how many times H shows up, how many times S shows up, and then for each of that letter in my text, I will get a counter. So let's say H shows up, I don't know, 13 times, and then S shows up 20 times, and then letter J shows up 6 times, and so on and so forth, right? But this table is sorted by letter, right? This table is sorted by letter. Why? Because I declare my letter count, the key of my map is the character. So this table is sorted by that letter. In my Huffman table, I do want to see the same entry, but sorted by the count. I want to use a min heap. I want to store the same pair in a min heap. Okay, that's why I have to transfer from my letter count table into my Huffman. And the way I do it, I have to take one item at a time using that loop. So the entry is each pair. So entry first will give me the letter, entry second will give me the count. And if I push that into my Huffman table, now everything will be sorted by the count column. Okay? Any question? Now, once we have the table built from the text, we can start combining the lowest two entries. We can start combining the lowest two entry and then insert the combined entry. Again, take the lowest two entry, insert the new entry, and so on and so forth. So tell me what to write next. Okay, let me put the comment here. Get the frequency count of each letter, and then put the frequency count into the table of Huffman priority queue. Put the character count into the Huffman priority queue. Okay, so now we are going to build the tree here. What should we do? Every time you want to find, remember what we did before? We always find the lowest two entries, right? Find the lowest two entries and then combine them and then make a new entry. Okay, so that means in my loop, I have to make sure that I have enough entry to pull. Right? I want to make sure that I have enough entry to pull. So I want to make sure that I do have at least two items in my table. Okay? Are you with me still? So then I will take the first entry. Okay, let me call it low one. Okay, low one will be Huffman dot top. Okay, and then I have to pop my table. And then I'm going to get the second lowest. The second lowest will be Huffman table dot top again, and I'm going to pop the table. Are you still with me so far? Okay, and then what should I do now?
Gotta create.
I have to create a new entry. The new entry will be
It's a pair.
a pair. Okay. The character doesn't really matter, right? I can use any number, any character, because the character doesn't really matter. I can just put as a question mark, but the entry, the count will be low 1 second plus low 2 second, right? Okay, because I want to combine the count for both. Take the two lowest entry, combine, insert back to the table. Question so far? Some of you look confused. So let me put comment here. So when you read the code later, then you will be able to understand what's going on. Okay, and then reinsert, combine the two entries, and reinsert into the table. Okay, now so far so good, but we are missing the important part, because the more important part is you have to build the tree, right? We don't build the tree yet.
Okay.
We don't build the tree yet, so we do have to build the tree, because without the tree, you're not going to be able to find the actual code, okay? Because the code, the bit combination for each letter will be known after you explore each branch of the tree and then find the 0-1 combination. So in order to build the tree, then I do need to make a real node. Okay, I do need to make a real node. Okay, so let me go back here. What if instead of keeping just a number and the letter, I mean the count, okay, what if I change each node into left pointer, right pointer, and then character and count? So basically I'm adding 2 pointers for each element. Are you with me? Okay. Why? Because when I create that, I should be able to link left and right. Okay. So now I'm going to change that structure from a pair of character and int. I know we can use tuple. We can use tuple, right? Tuple with 4 items, but the code will be too messy. So what I'm going to do here, I'm going to create a structure. I'm going to create a structure for that one node. Okay, so I'm going to call it, let me call it class Huffman node. So what do I have in the Huffman node? I will have the character, I will have the count, and I will have the left right pointer.
Screen.
Oops, sorry. Thank you. Okay. So I'm replacing the pair character and int with a Huffman node. So I'm keeping track of data, count, and left right pointer. Okay. So now in my priority queue, I want to keep priority queue of Huffman node pointers. Are you with me still? Okay. In my priority queue, instead of keeping track of a pair, I want to keep track of Huffman node pointer. So I'm going to replace the pair with Huffman node pointer. Okay, I'm going to replace that with Huffman node pointer. My vector will be a vector of Huffman node pointer. My comparison function will be comparing two Huffman node pointer. Question?
You can't use one that second, two that second.
Nope, you're right.
Okay.
I have to use one arrow count
Okay.
and 2 arrow count. Are you still with me? I'm replacing the pair with Huffman node pointer, right? Because I should be able to build the tree as I merge. Should be able to build the tree. So let's compile. Make sure that no compile error. Oh, I do have a compile error. That compile error is this unknown Huffman because I have to put that declaration before I declare my class. Okay, recompile, Control B. B count is a private member. I have to change that to public. Save, Control B, beep again. That beep is from push. Of course, my push has to be different, right? My push has to be different.
Yes.
Okay, so that one has to be different, and I do have to replace that line. Okay, that end place is not going to work. Okay, now what should I do? every time I insert, I do have to create a new node. Okay, and then I'm going to place new data. The data will be the letter, which is n3.first. Okay, and then the count will be n3.second. And then make sure I initialize left and right to null. And here I'm going to push my new node. Question so far? So when I get the low one, low one will be a pointer to node, right? So low one is actually Huffman node pointer, and low 2 is also an Huffman node pointer because I don't use a pair anymore. I keep everything in a node, and the reason I use pointer because that allows me to build my tree structure by using pointers. So then I'm going to create a new node here. My new node will be to combine the two, and I have to just declare a new node, a new Huffman node. Oops. And in my entry, combine arrow data. I don't really care about the character in my combine node. I just put a question mark. But in my count, I do want to combine low 1 count and low 2 count. Low 1 arrow count plus low 2 arrow count. And I can now push that node, combined node together. Okay, any question? What are we missing now? Louder?
Left and right children of that.
Left and right children? Yep, you're right. I need to put combine left to low 1, and I want to say combine right low 2. So I built the tree, right? I touch the two combined nodes and then point my left child to low 1, point my right child to low 2. So as I merge, build the tree, insert the new entry in my priority queue, and then keep going. Okay? Question so far? Yes, Mark.
Who's at the top of the Huffman table?
Who is at the top of the Huffman
The
table?
most frequent or the least frequent?
I'm not sure what your question is.
When you take the node off the top.
The one with the lowest count.
Okay.
The one with the lowest count, right? Because we make the Huffman table into a min heap. Remember, this is a min heap. Okay? Because we supply our own compare function, and the compare function will check for greater, so then we get a min heap from our Huffman table. Okay?
Yep.
So then we get entry with the lowest count, and what is missing is, I'm missing one entry, right? When do we stop the while loop? I stop the while loop when potentially the Huffman table is not empty yet. Because my condition is Huffman size greater or equal to 2. That means what? That means when I stop the loop, I may have one entry left in my table, right? Do you see that problem? Okay. That one entry has to be merged with who? That one entry must be the largest count, entry with the largest count, right? And that one entry has to be merged with the most recent parent. That one entry has to be merged with the most recent parent. Okay? Because that's the only one left. Okay? So that one entry has to be merged with the most recent parent. That means I have to declare Huffman node outside of my while loop. Okay? Combined, but I do instantiate combined inside the loop, but I want to declare it outside because that allows me to work after the while loop to merge the last entry from my table. In this case, I'm going to say Huffman node last. We'll get the copy from Huffman, from Huffman table. Oops. Huffman table dot top. Okay, and then I do want to combine. When I combine, I have to create a new node, and that node will be the new root. Root, new Huffman node, and that root will combine. So the data is nothing important. I can just put a star, it doesn't really matter. And the count has to be the count from the last parent, combined count, plus the last count. And then root left will be the combined pointer, and then root right will be the last. Combined, what's wrong with that?
Is that out of scope?
Is it out of scope?
They know the initialize.
Oh, it's not initialized, you're right. Thank you. Bless you. Okay, question? Am I too fast? Maybe. So any question? Any part that you want to explain again? Start over? Ruben, do you have a question?
Yeah, isn't the most frequent character at the top of the heap?
The most frequent characters is at the top of the heap, you're right. But those nodes will be combined first. Right? The lowest entry will be combined first. Okay? The next lowest entry will be combined next. So the most frequently occurring entries will be combined very late.
Right.
That's good. Because if you combine an entry first, the path from the root will be longer. So you want to give longer bits to those characters, right? Entries that you combine late during the process will be very close to the root. When that entry is close to the root, then you will give a short amount of bits. So, what is your question?
So, which one is at the top of the queue then?
When you start, before you do anything, before you build the tree, the ladder with the smallest count will be at the top of the heap.
And so at the end.
At the end, those entries will disappear because we remove, right? Every time we take two entries, we remove them, okay? And then we insert a new entry with a higher count, right? So if you look at the part here, every time we take the top two, every time we take the top two, we remove them, and then we insert a new entry with a higher count. Okay? Any other question? Yes, Zach.
Why do we have to combine the two after we run through that loop?
Why do we have to combine the two at the end of the loop? Because in my while condition, I will do this process when we have at least 2 entries. So when we stop the loop, we may see 1 entry remaining that we didn't combine yet.
Well, wouldn't you just, since you push your combined node back on priority queue every time,
Yep.
shouldn't that run until there's one node that holds all the entries in it?
You're right. You're right. Yes, you're right.
That's like
Yeah.
And actually, for this, why
Everybody agree with Zach?
Should we go?
Okay. So if you remove the last 2, so let's say we do have the last 2 nodes, right? And then, so let's say this is the last 2, and then we remove those 2, and we combine those 2, and we insert a new one. Okay. At that point, we're gonna stop the loop, and we have 1 entry remaining in the table, and that entry is already a combination of the last 2. You're right. Yep. So we don't need the last line. That means combined will be the root. Yes? No? Yes, Nick?
Question. If you're saying combine left to low 1 and low 2, are you just making just a combined node as be just 2 smaller nodes underneath it, and then you can only combine those 2 smaller nodes underneath it when we connect it to the other node at all?
We are doing this picture here, right? When we combine the lowest 2, we make a new node,
Right.
and left and right has to be pointing to the 2 nodes that we just combined. Okay, and then we insert that as a new node.
Okay.
Okay, and then the same thing, when we combine this and that, you create a new node that will add the count from both, and the left child will be this, and the right child will be that.
Oh, okay, never mind. Using the same table over again.
Yeah. You reinsert to the same table.
Okay,
Yes.
so, okay.
Yeah. Okay. So, any other question before you leave? Okay, I'll see you next week.
So